Ski width. Why does it matter? First of all, what is the ski width? Skis have been compared to an hourglass because they're wider in the tip and tail and narrower in the middle. What we are concerned about is the middle, the width under the foot. If you look at the tail of the ski, you will see some printed numbers. On this ski, the first number, 175, represents the ski length in centimeters. Then three values, the tip, waist, and tail. The 113.5 is the width of the tip in millimeters. Then 69 millimeters, which is the waist width. This is the one that represents the ski width. Lastly, 96.5 is the tail in millimeters. The R stands for radius, which here is 18.5 meters, meaning that if the ski was laid flat on the ground, you could scribe a circle with an 18.5 meter radius. Don't get that mixed up with the radius of the turn. That is a cosine function, and that is a subject for another time. The ski can be a tool for performance, a learning tool, and have an impact on the skier's health. Let's look at performance. Turn transition duration. How long does it take to initiate a turn? Edge grip. Can the skier hold the ski on edge? And more control. Does the ski offer rack and pinion steering? Is it accurate? Balance and performance depend on the skier's center of mass. From the center of mass, there is a line of action to the base of support. In this case, it is the skier's edge. This is what holds the ski on the slope and maintains the line through the turn. On an ice skate, the line of action goes to the edge also, which is right under the middle of the skater's foot. On the ski, this line of action goes to the ski edge, the edge that is doing the edging. If the ski is wider, the line of action is moved even farther away from the center of the foot. This creates a torque like a teeter-totter. Although not the same class of lever, the physics are the same. This torque, or moment of force, is increased the longer the lever arm, which again is the ski's width. So let's move from performance to learning. So why do we teach a wedge? It gives the student a larger base of support, which makes balance easier. So why are wide skis so popular? It's easy to balance, which makes them a good learning tool. So what are we learning? First, what are the muscles doing? And is skiing on a wide ski the same or have different muscle involvement compared to a narrow ski? Let's look at and use two muscles that are essential for successful skiing. The G-max, or gluteus maximus, is the big one right behind you. It is an extensor of the hip. It externally rotates the leg and assists in abduction and adduction. And the G-med, or gluteus medius, this is the one that is responsible for standing or balancing on the outside ski. Yes, pretty important. The numbers are voltage from the muscles while skiing. The higher the voltage, the more that muscle is involved in the task. So when skiing on a wide ski, the gluteus maximus has twice the voltage compared to the narrow ski. Don't think of this as twice the effort, but think of it as the muscle being used in a different way. Okay, that was free skiing. We can see the same results while skiing a brush course. Looking at the gluteus medius, we see the opposite. Free skiing on the narrow ski in the brush course has more muscle activity. Bottom line, different ski, different muscle activity. So if muscle activity or involvement is different for each ski, are the skiing results different? So here's the edge angle for the two skis. First, the wide ski has a lower edge angle, and looking at the turn development after the edge change, we can see the tipping of the ski is more gradual. Then it seems to take longer to get off the old edge and onto the new edge. Okay, that data was for on-piste skiing. What about powder? There is some research with wide and narrow skis. Ski characteristics from different width skis while powder skiing. Here's a glimpse of the results. Whether on the groomed or in the powder, the peak edge angle was greater with the narrow ski, with the largest difference being on the groomed, as would be expected. The time per turn was longer for the wide ski, regardless of the snow type. This makes intuitive sense since it takes more time for the edge change with the wide ski. Then it also seems that where pressure or edge change is always later in the powder. The angular velocity refers to the rotation along the longitudinal axis. This is the speed of the edge change. It is not surprising that the wide ski takes longer to change edges on the groomed and in the powder. So what did we learn? There is different muscle activity. Max edge angle is less regardless of snow. It takes longer to change edges with the wide ski. The wide ski is slower. Skeletal health. Let's look at the health ramifications. Earlier we saw that increasing the width of the ski adds torque to the ski snow lever system. Martin Zurko from Slovenia had an excellent study where he had skis made to the same specifications, only the width differed. Controlling for the many extraneous variables with skis, he found that the torque on the knee was significantly greater with the wide ski. You can see in the right-hand photo with the increased lateral edge angle. This torque is not a one-time incident as happens with an ACL rupture, but a stress accumulated over time. There are two reasons we saw less edge angle with the wide ski. First, it is just very difficult to tip the wide ski. Second, the body senses the torque which translates up the kinematic chain to the knee. The body is smart. It is trying to reduce the torque, knowing it is not a healthy situation. Let's conclude by mentioning professionalism. With this equipment, would you trust this guy? With boots on the wrong feet, you might question his expertise. Just remember, what you do, what you say, and even your equipment reveal a lot about your professionalism and credibility.